Each of these substances forms ions in solution. 1 mole of the following substances is dissolved in 1 meter cubed of water. Which solution contains the greatest number of ions?
Yeah, so which one would it be?
Um,
And if it's decimeter cubed, it's very different to centimeters cubed. Make sure you don't
would
make
it be
right.
um ammonium sulfate? Cause you just like multiply it, right? Would it be ammonium sulfate?
Okay, how many ions does it have?
8?
Okay, is that what you think? How many
Yeah.
ion ions does iron 3 chloride have?
Oh, it has 9 because there's 3 of them, right? 3 ions? Or
Maybe
it's only
so maybe we should break it up into its ions, right? So figure it out, right? That could be really, really helpful. Okay, so let's do the first question together. So let's say um let's start with the easiest potassium bromide out into its ions, right? What two ions make up potassium bromide?
potassium and bromine.
Okay, what are the ions there? So that's K plus is potassium. Do you know how I know it's K plus?
Because there's like a list of them and then like the most common ones. Or is it to do with like the group?
Correct. It's to do with the group. So now, quick question. Do you have your periodic table in front of you?
No, but I can search one up.
Yeah, could you search one up to make sure you have it in front of you?
Yeah, I have it in front of me now.
All right, good. Um, that's super important. Periodic table. Great. And then can you tell me what group potassium is in?
Um, can't find it. Oh, it's in group 1
Okay, so why do you think it forms the K plus ion?
because it needs to gain 1 electron in its outer shell.
Absolutely brilliant and correct. Okay, great. It doesn't need to gain. It has 1 electron in its outer shell. So when it needs to react, what's the easiest and quickest thing for it to do? Gain 7 electrons
To gain 1?
or lose one?
Oh, lose 1?
Lose one, right? Do you know why it's lose one? Just to confirm that it has 1 electron in its outer shell of the group one, right? The easiest thing for it to do is get rid of that one. An electron is negative. When you get rid of a negative, you become positive. That's why it's K plus.
Positive?
Yep, simple as
Yeah.
that. Don't overcomplicate it past that level, okay? That's the kind of level of thinking you're expected at GCSE chemistry. Now, bromine is the next one, right? What do you think bromine's ion is?
Um, is it 2 minus?
Why do you think it's 2 minus?
Because it has to gain 2
What group is it?
electrons. It's in group 7.
How many electrons can fit in the outer shell?
Oh, oh, it's 1 minus then, because there's
That's
7.
correct. Br minus. That's absolutely correct, right? And to form KBr, we call this the swap and drop. Have you heard it before?
No.
All right, okay, right? For every one
Oh,
positive, yeah, so for every one positive, there's one negative, so it just becomes KBr, okay? I'll use the swap and drop in a later example, but for this to form KBr, we only need one potassium and one bromine, therefore there are only two ions, okay?
okay.
Let's do the same for this, okay? Magnesium, what's the ion for magnesium?
Mg, is it 2 plus?
Correct, good job. All right, let's move quicker now just for time's sake. All right, and then what about nitrate, NO3? That's nitrate. What do you think it is?
NO3 minus.
That's absolutely correct. How did you know that?
Our teacher just makes us like learn them.
Yep, and that's the first thing that the teacher's done. And that's super good because that's correct. Okay, now this is now where we do the swap and drop. Okay, just focus on the ions. I know this three here is going to really confuse you, but I need you to sort of ignore it for now. Okay, the swap and drop means you focus on the one. Remember, there's an imaginary one here, right?
Yeah.
Yep. It means in order to balance the ions and combine them, right? we're going to swap the numbers and then bring it down. So one comes over here and we bring it down, and two comes over here and we bring it down, right? So when you bring those two together, it becomes Mg1.
1 plus.
Yeah, but we're not going to put the one there. When I mean swap and drop, remember, we're dropping it down. So it's Mg1, but we're not putting the one there because we don't do that in chemistry, right? And then what does
Yeah.
NO3 become?
NO, just does it stay the same?
Yeah, NO3 2.
NO3.
Do you know why it becomes 2? Because for magnesium is 2 plus, it means it's going to require 2 nitrate ions for every magnesium ion to make it balance. Think about it. We need 2 minus to balance the 2 plus. That's the best way to do it.
Yeah.
Yep. Okay, so we need to forget the swap and drop for a second. I think this way is probably better for you to learn it because it seems you might understand this better. Okay, so you need 2 NO3 minuses for every Mg. That's why it's Mg NO3 2. That's exactly how we do it. Do you understand that?
Yeah.
Okay, cool. Because you're gonna do the next one on your own. Okay, let's do iron
Okay.
chloride. Okay, iron chloride. Let's move over here where we've got space and try and get it done. Right, iron chloride. Let's try and get it done. I'm changing the color now to green. Okay, so how many ions for iron 3 chloride in
Is
for
it
iron?
is it 3 plus?
Correct, right? It's in the name. Brilliant. And what about chlorine?
Cl2 minus?
Check your periodic table.
Um, oh, 1 minus.
So Cl minus. So
Yeah.
therefore,
So
how many ions would it take to balance Fe3? How many chlorine?
it would take 3.
Correct. And that's why, by the way, in the formula we have it as FeCl3, right? So how many
Yeah.
ions in total in this case?
3.
Nope, in total, including iron and chlorine, how many ions?
Oh, 4.
Correct. And back to the magnesium question, how many ions in total were over here?
Um, 3. No,
Correct.
7.
Three. It's the ions. Remember,
Okay.
ions are the ones with the charges, not the molecules, okay? You had
Okay.
one Mg2 plus and two NO3 minuses. Here you had one Fe3 plus and three Cl minuses. Are you noticing it? Yeah?
Yeah.
Okay, can you lead me, if you can, and if you do remember it, on the last one, ammonium sulfate. Tell me about that one.
Um, NH3, so would that be for N is it NO3 minus?
NH4, by the way. It's over here.
Oh, do you always have to do like for the
Yep.
do you
So,
always need to do the ions or can you
yeah,
just
always ions.
multiply out the numbers?
No ions. You have to do the ions to figure it out because you're working backwards, right? So what's NH4?
Yeah.
What ion does it form?
Um, is it 1 minus?
Yes, it's a plus. It's just a plus. NH4 is a plus. You
Oh,
have to remember that. And can you remember what it is for sulfate? SO4.
minus.
Nope, it's SO4 2 minus, okay?
Oh, okay.
So bring them together. What do you think we need? Because we have two minuses and we have one plus. So what do you think it will take?
You need 2 pluses.
So you need another NH4 plus, right?
Yeah.
Good. And by the way, that then gives the equation, doesn't it, of NH4, two of them, SO4, right? That makes sense, doesn't it?
Yeah.
Cool. How many ions in total here?
Um, 4.
Count them again. How many? They're on the screen. Don't get confused.
Is it?
One, two, three, right? You told me two
Oh,
NH
so it's just
and one SO4 2 minus, right?
oh, I was counting the numbers, not the like
Ions. Yeah, the ions are things with the charges. Remember, I said that.
yeah,
Yep. So how many ions in this case?
3.
All right, cool. So which one has the most amount of ions?
Um, iron chloride.
Correct. Now, do you understand how we've done that?
Yeah.
Do you understand how ions are different from the molecule numbers at the bottom?
Yeah.
right? NH4 is a molecule in its own, but nitrogen and hydrogen may not form ions in this case. It actually is just ammonium sulfate that's an ionic combination of ammonia and sulfate, okay? So this is
Okay.
good work there. And now that you get that, that's super good. Do you think you'll be able to tackle another question like this on your own?
Yeah.
Good job. All right, cool. So, do you want us to skip the next question or quickly go through it? This is a question on sodium hydroxide being neutralized. It's similar to like a titration type question.
Maybe go through it.
Yep. Okay, cool. It's a four marker, so that means you need four solid points. Okay. Have you take your time, just have 20 seconds, 30 seconds to read through it, and then we'll talk about it, right? And in fact, you know what? Take a little time to think of an answer, and then we'll discuss.
Okay.
All right. So, have you thought through?
Yeah. So then, is it because if there's an acid, then sodium hydroxide's a base, and then it's alkali?
So,
Is it?
Lisa, just before I don't want to stop you down the tangent. What's the question asking you to do exactly? Tell me exactly what it's asking you to do. Don't overcomplicate.
Oh, to compare the temperature changes when it's neutralized with each of these two acids
Then just not just to compare it. What does it say? The first three words of that paragraph you just read.
to devise a plan.
That's all you need to do. It doesn't actually ask you to compare it. It wants the plan to compare it.
So then, do you just like, is that just like setting up the titrations thing experiment?
Exactly, pretty much like that. But this is temperature one, not titration, but it's similar, right? It wants you to devise a plan to compare temperature changes produced when sodium hydroxide solution is neutralized with each of these two acids. So what do you think you'll do?
So then you'd have you'd add the solutions. No, you'd measure the temperature before the solution is added, and then you measure it again once it's added.
Brilliant. I think you have all the ideas and you're putting it in there, and I love it. So what we're going to do, Lisa, is let's really structure this to get 4 marks, 4 points, right?
Okay.
First of all, we know loads of different factors that affect an experiment. We only want to make the temperature is the only thing that changes, right? Therefore, everything else has to be fixed. So to make sure everything else is fixed, what would you first do?
Um, you'd measure out measure
Yep, good, good,
out the sodium hydroxide.
good. A fixed amount of sodium hydroxide, of sodium hydroxide. Okay. Okay, black is just such an ugly color. Let's go blue. Okay, of sodium hydroxide. All right, sweet. Do you know what the formula for sodium hydroxide is, anyways? I just like students doing this just so you can remember it.
Is it NaOH?
That's absolutely perfect. Right, good. NaOH. That's perfect. All right, go on.
And then you
Oh, that's a little two there. Sorry, I can't draw a little two just yet. But yeah, carry on.
And then you add um in one like beaker you'd add hydrochloric acid, and in one you'd add the ethanoic acid, and then measure the change.
It's just NOH, by the way, no NOH, so ignore me. All right, cool. Yeah.
Oh, okay.
Yeah, so you measure out a fixed amount of each acid, right?
Yeah.
That's good. That's really good, right? So that's pretty much it. Pretty much your first couple of marks, okay? Right. What next do you think you'll do?
Add the fixed amount of each acid to the sodium hydroxide.
No, no, no. Before we do that, what did you say we should measure?
Use
Measure.
our beaker. Oh,
Yeah.
measure the temperature.
Yep. Okay. So, and then after measuring the temperature, you add both of them, stir and mix, and then see what happens when you change the temperature. Does that make sense? Make sense?
Yeah.
Right.
Yeah,
So
it makes sense.
measure temperature, mix, and stir each one, and see what happens when the temperature changes. Yeah. Okay.
Yeah.
So that's
Do
quite
you have to
simple.
say
You put your thermometer. No, we'll be even more clear. 1 second. How we're gonna do it, right? To do this, we can say we'll put a thermometer in the sodium hydroxide, right? We'll add the acid completely and see how the temperature changes. Okay? In the NaOH, add the acid and see how the temperature changes over a fixed time. Okay? That last
yeah.
sentence is tying everything together. Does that make sense?
Yeah, it makes sense.
Okay, cool. So don't get bogged down in the details of these questions, which is so super, super easy to do. Okay? All right, good job.
I think they word it really complicated.
They worded it, Lisa. It, I'm not going to defend you there. This is not a weirdly worded question. How else were they meant to ask this question other than devise a plan to compare the temperature changes produced when this is neutralized with each of these acids? It's just actually
I'm
about you
not sure.
taking time to read the question and not hurrying up, right? Obviously, you're super smart, you're super clever, right? And that's not going to be your issue when you're doing these questions. I know you're super good and you can do all these questions with your knowledge base, but it's actually about slowing down and really asking yourself what the question is saying. And most of the times, if you did that, you'll absolutely be getting the top marks that you deserve, right?
Yeah.
So you need to make sure that like you read the question. So favorite saying to say is RTFQ, which is read the full question, okay?
Okay.
All right, cool. Good job.